right, I've got questions 3 and 4 up on the board here for you. So this was topic 4. Now we're doing questions 3 and 4, and I've got them written up here on the board. 2 different functions that I'm asking you to evaluate at several places. Just want to mention a couple of things here. First of all, this function is the first one we've seen so far where the x appears in more than one place. That's okay. That means we're plugging in that number or that expression more than one place. Wherever there's an x, you're going to put the placeholder, the empty parentheses, and that's where you're going to be plugging in your input. The second thing is that the directions specify that if you get something that's undefined, write the word undefined. Okay? And that will happen with some of these. That didn't happen in the first 2 functions that we worked with because we were working with functions that were defined everywhere. Their domain was all real numbers. But when I have functions where there's a denominator or where I'm taking an even root, there are some restrictions on the domain. And if you're asked to plug in a number that's not in the domain, you want to just write undefined. Okay, so pause the video if you haven't already worked these out, and try working these out, and then turn back in to check your answers. Okay, so for problem 3, again, I'm going to just put parentheses around the x because that's just a placeholder for my input. So if I'm evaluating h somewhere, I'm going to just copy down that formula, but I'm going to replace the x with just a placeholder for my input. Now this says we were supposed to plug in 6, so I put 6 in both of those positions, and then I do the math. 6 minus 3 is 3 over 8. It's a fraction. I want to double check that that's in lowest terms. It is, so we're good. Okay, same thing when I'm doing h of 3. So for h of 3, I'm going to copy the function, but I'm replacing the x with just empty parentheses, a placeholder for my input. And then what we're plugging in, what goes in that position, is 3. So 3 minus 3 is 0. 3 plus 2 is 5. I've got 0 on top of a fraction and 5 on the bottom. As long as I don't have 0 on the bottom, that's totally fine. 0 can be on the top. This is just 0 divided by 5, which is 0. In the next part, we're looking at h of negative 2. So I start out the same. I copy the formula, replacing the x with just a placeholder for my input. Then my input was supposed to be negative 2. Now if I work that out, negative 2 minus 3 is negative 5. Negative 2 plus 2 would be 0. And you may notice I'm sort of starting to shake because I don't want that. We cannot divide by 0. As soon as I get that, I'm going to cross it out. And I hope you're going to cross it out too. Because if you turn in work and you have 0 written on the bottom, you have made a mistake. Now, you did what you were supposed to do. The mistake is in not saying, oh, that's not allowed. This is undefined. Okay. I cannot divide by 0, so it's not okay to have 0 in the denominator. That makes this undefined. And I'm going to be very, very picky about this. You got to cross that off if you actually wrote it. Now, you might have noticed from the beginning, hey, wait, I can't plug in negative 2 because negative 2 would make the denominator 0. Now, if you notice that and you didn't ever write this, then you don't have anything to cross out. You can just write the word undefined because that would put 0 on the bottom. Okay. But I don't want to see, and I see this a lot with students, I will see people write this equals negative 5 over 0 undefined. You're telling me 2 different things. You're telling me that it's undefined, and you're telling me that it equals something. Can't be both things. It is undefined. So do not write this. And I'm really, really picky about that and really strict about enforcing that because a lot of times I see students in calculus who are haunted by this. They keep writing things like this, and so they're not realizing that, hey, this is undefined. And it promotes a bad way of thinking to write things that aren't defined. Not only that, it's wrong, okay? We can't divide by zero. Now, let's talk really quickly about why we can't divide by zero, and then we'll come back and do part D. So I'm just going to clear some space here. Okay. If I have 6 divided by 3, that equals 2. Okay. And anytime I have a division problem, there's a corresponding multiplication problem. 6 is 2 times 3. So if I take this number and multiply by the number I was dividing by, I get this. I'm basically saying, how many times does 3 go into 6? Well, it goes in twice. So if I have 2 copies of 3, that's going to build me a 6. If I were to try to divide by 0, now, I can't actually do that. So I'm just writing this now to illustrate why I can't. If I were to do that, the corresponding multiplication problem would be 0 times question mark equals 6. But there's nothing I can multiply by 0 in order to get 6. It's not going to happen because 0 times anything is 0. So there's no corresponding multiplication problem because that division problem does not make sense. I can have 0 on top. If I have 0, if I have nothing, and have 6 people that I want to share it with, I can share my nothingness with 6 people. Everybody gets 1/6 of my nothingness, which is nothing. Okay. But I cannot divide by 0. This is almost like if I had a cookie jar that held 6 cookies. How many times could I take 3 cookies out before the cookie jar would be empty? Well, I take out 3 cookies. That was one time. There are 3 cookies left. I take out those 3 cookies. That's the second time. The cookie jar is empty. How many times can I take out nothing before it's empty? Doesn't make any sense. If I've got a cookie jar, there are 6 cookies in it, and I take none of them out, there are still 6 cookies. I haven't changed anything. So division by 0 does not make sense. Don't write it. Now, it's okay if you didn't notice that you weren't allowed to plug something in. So you ended up writing out what you would get if you plugged it in, and then you say, oh my goodness, there's a 0 on the bottom. As long as you cross it out, that's totally fine. But do cross it out and tell me it's undefined. Okay, let's take a look at part D. So, we're looking at h of x plus a. So h of x plus a is, again, I just copy the formula for h, but with parentheses as my placeholders for my input. And then x plus a goes inside all of the parentheses. And here, there's not a whole lot that I can do to simplify. I'm going to get x plus a minus 3 over x plus a plus 2. I don't have any like terms, so I can't combine. Do not make the mistake of trying to cancel. We can't cancel across addition and subtraction. So if I just think about it with numbers, if I have, let's say I had 2 minus 3 over 2 plus 2. I can't cancel those 2's. This is actually 2 minus 3 is negative 1 over 4. If I try to cancel those 2's, I'm not going to get negative 1/4. Okay? Anytime you have a fraction, there are sort of understood parentheses around the top and the bottom. And so if you've got addition or subtraction inside of that, you can't cancel. You can only cancel things that are connected with multiplication and division. So this would be my final answer for part D. Okay, so let's try question number 4. So my function k of x was the square root of 4 minus x. So when I'm looking at k of negative 5, I'm going to just recopy that, but I'm going to replace x with just a placeholder for my input. So I'll have the square root of 4 minus, and then inside of those parentheses, I'm going to put what I'm plugging in. So here I'm going to plug in a negative 5. Now, 4 minus a negative 5 is 4 plus 5, so that's 9. And the square root of 9 is 3. Excellent. You might have said, hey, wait, that's a negative. I can't take the square root of a negative. It's true. We can't take the square root of a negative. But that doesn't mean you can't plug in a number just because that's negative, just because there's a square root in the problem. Because in this case, we were subtracting that negative number. So I didn't end up taking the square root of a negative number, even though I plugged in a negative number. Now, if I look at k of 5, again, I'm going to just copy my formula for k, replacing x with a placeholder for the input. Then what's in the parentheses there goes in the parentheses there. I'm going to get the square root of negative 1. Now I do have a negative under the radical, and so I'm going to say this is undefined. And again, I'm going to just cross it out. That tells me 5 was not in the domain of this function. It's not an acceptable input. Nothing wrong with my thought process of trying to plug it in and see what happened, but part of my job is to recognize, oh wait, that's not a legitimate result. Now, later this semester, we will be working in what we call the complex numbers. When we work in the complex numbers, we're allowed to take square roots of negatives. But right now, we are just working in the real numbers. Real numbers are either positive or 0 or negative, and we can't take even roots of negative numbers if we're working in the real number system. So, the two scenarios that we've seen so far where you're going to get something that's undefined are if when you plug in something, it puts a 0 on the bottom, that's undefined. Don't write it. If you did write it, cross it off. Okay. If you end up taking an even root of a negative, that's undefined. Okay.